Hello everyone, welcome to my channel GVS Chem. In this video, I am going to explain the electrochemical cell, electrochemistry part 2. This is the revision series for board examination. Please subscribe to my channel, like, share and comment on my videos. In the previous video, I taught and revised the electrochemistry up to a certain extent. So what we learnt in the previous video: conductance, specific conductance, molar conductivity, factors affecting the molar conductivity in case of weak electrolytes, strong electrolytes, and so. Now in this video I am going to explain the electrolytic cell, electrochemical series, Nernst equation, factors affecting the product formation during the electrolysis, and others. What is a electrochemical cell? Electrochemical cell is the device in which chemical energy converts to electrical energy. Chemical energy converts to electrical energy, and of course such a device we call it as a galvanic cell. Then what is the other way? That is, when electricity passes through a solution, then reaction takes place. Such a device is known as a electrolytic cell. So electrolytic cell, electrical energy converts to chemical reaction. So this is electrolytic cell. In electrolytic cell, chemical energy is used and electrical energy is used and chemical reaction takes place, whereas in electrochemical cell, that is galvanic cell, chemical reaction takes place and electrical energy is produced. Now let us discuss about this galvanic cell. Now here in this diagram, this is the zinc sulfate container and this is the copper sulfate container. In zinc sulfate container, this is the zinc rod. Zinc rod is dipped in zinc sulfate solution and copper rod is dipped in copper sulfate solution. And here this is salt bridge. What is a salt bridge? The paste of potassium chloride or ammonium chloride, etc. is filled in this inverted U-shaped tube, and of course it is kept in both the solutions. Now, so here current passes, electrons pass from zinc to copper. Therefore, deflection is seen in this galvanometer. So what is happening here? Zinc gives zinc 2 plus ions plus 2 electrons. Therefore here oxidation takes place. Therefore this is oxidation half cell. On the other hand, copper ions from the solution takes 2 electrons and become copper, and of course this copper stick here. Then what is this reaction? This is a reduction. So oxidation takes place in this zinc sulfate container and reduction takes place in the copper sulfate container. Therefore this is oxidation half cell and this is reduction half cell. So both oxidation and reduction take place in two different containers, of course. Therefore this total setup is referred as redox reactions. So redox reactions are responsible for the production of electricity in galvanic cells. Now if we apply some external voltage, so this is the external voltage here. So this is external voltage is applied. So what happens if external voltage is applied? If external voltage is applied and slowly it increases. If the external voltage is slowly increases and reaches to 1.1 volt. Why it reaches to 1.1 volt? Because this galvanic cell produces a maximum EMF or potential difference of 1.1. So if we increase the voltage, external voltage slowly up till it reaches 1.1 volt, the reaction goes as usual. Which means passage of electrons take place from zinc container to copper sulfate container. If external voltage E external reaches to 1.1, then reaction stops. Then no current flows in the cell. If E external is more than 1.1, if external voltage is more than 1.1, that is than the voltage produced by the cell, then what happens? Electron passage takes place in the reverse direction in this manner. That is from copper container to zinc container. So these are the conditions. Now let us discuss the functions of salt bridge. So salt bridge is a inverted U-shaped tube filled with paste of potassium chloride, ammonium chloride, etc. So salt bridge completes the circuit. Salt bridge completes the circuit and sees that electricity passage takes place. So electricity passage takes place. If the circuit is not completed, electricity does not pass. Therefore, salt bridge completes the circuit, therefore sees that the passage of electricity continues. Number 2, it prevents the accumulation of ions in each container, in each half cell. It prevents the accumulation of ions in each cell, so that continuous supply of electrons is possible. So these are the functions of the salt bridge. So if E external is less than EMF of the cell, therefore what happens? Flow of electrons is from zinc to copper. That means electricity from the galvanic cell is drawn out. If E external is equal to EMF of the cell, then no flow of electrons. If E external is greater than EMF, then what happens? Electron flow is opposite direction. That means from copper to zinc. Now I shall take a single half cell, and of course let us try to understand this. So this is what happens? This is a zinc sulfate container in which this is the zinc rod. Now what happens? Zinc atom from the zinc rod continuously loses electrons and become zinc 2 plus ion, therefore 2 electrons. Therefore what happens? Oxidation takes place here. As oxidation takes place, and as electrons are continuously releasing, therefore what happens? There will be negative charge. So there will be negative charge on the zinc rod. Therefore zinc rod is assigned with negative sign. And what do you call the electrode at which oxidation takes place? The electrode at which oxidation takes place is anode. So this anode, it is assigned with negative charge because negative charge accumulates here. Therefore what happens? Zinc container is at the left side, this is L, and it is oxidation takes place O. This is anode A, and it is negative, anode negative. Therefore, you take all these letters L, O, A, N, lone. So, what is this L, O, A, N? Left side oxidation, anode, and negative. So, you remember this. Therefore, it is easy to understand, easy to remember, easy to recollect which half cell is oxidation half cell and which is reduction half cell, and what are the charges on those electrodes, etc., etc. So, this is lone means left oxidation, anode, negative. Now, see here, what happens as zinc ions, zinc atoms lose electrons continuously. What happens? All these are the zinc ions, excess zinc ions accumulate here. Therefore, there will be a difference in the charges between zinc ions and zinc rod. Therefore, a difference in charge between zinc rod and zinc ions is established. Difference in charge in between zinc rod and zinc ions established, and of course this difference in charge is called, what do we call this? This is called electrode potential. Electrode potential. So, this electrode potential is produced in zinc container, that is oxidation half cell, as well as copper container, that is reduction half cell. So, in both the half cells, electrode potential is established. Now, E naught cell. E means EMF. E naught cell means this naught represents standard conditions. That means the EMF of the cell under standard conditions. What are the standard conditions? The EMF of the cell at normal temperature. Normal temperature means 298 K when all the solutions are, when all the electrolytes are of unit concentration. Unit concentration means 1 molar concentration. When solutions are in 1 molar concentrations conditions, whatever be the EMF obtained, that is called E naught, that is standard electromotive force. Okay, then how do we find the EMF of the cell? EMF of the cell, that is E naught cell equal to E naught cathode. E naught cathode. E naught cathode means electrode potential obtained at the reduction half cell minus E naught anode. So this is the formula to find the EMF of the cell. How do we find the electrode potential of an individual electrode? So electrode potential of an individual electrode can be measured by using a standard electrode. That standard electrode is a standard hydrogen electrode. Standard hydrogen electrode, SHE, standard hydrogen electrode. Now the arbitrary value of SHE, standard electrode potential, arbitrary value of potential of SHE is taken as 0. So it is recommended by IUPAC. So this, what is a standard hydrogen electrode? This standard hydrogen electrode, this is a container in which, so this is a container with 1m HCl. In this a platinum wire is dipped, which is connected to a platinum foil. This is the platinum foil. This platinum foil is coated with platinum powder. Right. Now this entire setup, this entire platinum tube is kept in a glass tube, and of course here this is here the hydrogen gas is passed at 1 bar. Hydrogen gas is passed at 1 bar. So this is a standard hydrogen electrode. Now this standard hydrogen electrode is connected to connected to the electrode whose potential is to be found. So SHE is connected to the electrode whose potential to be found. Whose potential to be found. For example, if SHE is connected to copper electrode, if SHE is connected to copper electrode, then electron flow is observed from SHE to copper electrode. If standard hydrogen electrode is connected to copper electrode, then electron flow is found from SHE to copper. In such case, SHE is anode, and copper is cathode. So this the galvanometer reading is found as plus 0.34 V. Therefore, the cell potential, how can we write? This is here cell potential or E0 cell. E0 cell equal to E right minus E left. E right means E cathode minus E anode. So this is 0.34 is equal to E copper 2 plus copper minus E0 PT H2 oblique H plus. So this is the E0 cell. Now what we wrote here, SHE, the standard hydrogen electrode SHE, arbitrary value of SHE is taken as 0. Therefore here this is therefore hydrogen electrode is 0. Therefore copper electrode equal to 0.34. So in this way we can find the electrode potential of copper. Like this by using standard hydrogen electrode we can find the electrode potentials of all the metals. Now how do we represent the cell? Cell notation or cell representation? Cell notation or cell representation. So the galvanic cell is zinc solid plus Cu2 plus aqueous gives zinc 2 plus aqueous plus Cu solid. So what is the oxidation half cell? This is oxidation half cell, and this is reduction half cell. Now the cell is written as anode should be on the left side, anode salt bridge cathode. Now how do we write the anode? Anode is here zinc solid, a single vertical line, zinc 2 plus aqueous. Salt bridge is represented by 2 vertical lines. So this is anode. Now what is cathode? Cathode is Cu2 plus aqueous oblique, that is single vertical line, Cu. Yes. Right. As concentrations are not given, we wrote only solid or aqueous solutions. If concentrations are given, in place of aqueous, we have to keep those concentrations. So this is the cell notation, cell representation. Now if a hydrogen electrode is given, so hydrogen electrode is connected to zinc electrode. So in this case, PT. Why do we write PT? Because hydrogen is a gas. That hydrogen, to release the hydrogen gas or to collect the hydrogen gas, one base is required. That base is platinum. Why do we use platinum? Because platinum is a passive electrode. It does not take part in the reactions. So such an electrode, either platinum or graphite electrode, should be used in case of a hydrogen electrode. So this is hydrogen. So hydrogen H2 gas 1 bar vertical line H plus, and of course salt bridge. Now this is zinc 2 plus aqueous oblique zinc solid. So this is anode, this is cathode. So galvanometer reading is found as minus 0.74 volt. Therefore, E naught cell is equal to E right minus E left. Implies, what is the galvanometer reading? Minus 0.74 V is equal to E right. E right means this is zinc. Zinc 2 plus oblique zinc minus E left. This is E H2 oblique H plus. So what is a, therefore this is minus 0.74 is equal to zinc electrode. And what is the hydrogen? Hydrogen in any way it is zero. Whether it acts as either anode or cathode. Therefore, E naught cell of zinc 2 plus oblique zinc is equal to, this is minus 0.74 V. So in this way we can find the electrode potentials of all the possible elements. So after finding the electrode potentials of all the possible metals, they are arranged in the increasing order of their electrode potentials. Electrochemical series and their applications, Nernst equation, I shall discuss in the next video. Thank you very much. Please subscribe to my channel, like, share and comment my videos.